Swayam Prabha. Digital India. Educated India.
Infrastructure management. See, most of my lectures are a little bit interactive. So I will sort of throw out a few questions at you and ask you to respond. Now, of course, for those of you who are watching this online, don't worry, I will sort of repeat what people are saying, so you'll get a gist of how the discussion happens, but do be prepared to participate. Okay? All right. So we'll go ahead and get started. I want to start off with some very simple questions. Okay? We're going to talk about infrastructure management. So my first question is very simple. What is infrastructure? What does it mean to you? It's a structural setup. Okay. What else? What are the, if somebody says infrastructure, what comes into your mind? What is infrastructure? So it's sort of a common sense question. Doesn't require any deep civil engineering knowledge. Yeah. Bit louder, please. Buildings. Okay. Buildings could be infrastructure. What else? Roads. All right. Bridges. Great. Dams. What else? Interior? Sorry, I'm not sure I got that. Okay, but a bunch of you have raised, some of you have probably even seen these slides earlier, I guess. So you've hit a lot of the things that were there on these slides. But essentially, when we talk about infrastructure, we talk about things like this, right? We talk about, roads, which are parts of infrastructure, dams, somebody brought this out, all kinds of water supply systems. This is a picture here of a sewage treatment plant which is used to treat wastewater, but there are water treatment plants, water pipelines. I mean, all of us need water, right, in our houses, in departments, in toilets, in kitchens, all of that, right? So that water has to come from somewhere. And so pipelines are built, treatment plants are built, and also all kinds of what we call urban systems. Some of you brought up buildings, right? But buildings are not the only form of infrastructure that we find in urban areas, right? You have urban transport. So this is a picture, as you can see, of a metro rail, right, that many cities in India are building. So all of this is infrastructure, right? Roads, power plants, dams, urban systems, etc. Why do we call them infrastructure? Any idea? Anyone know why we call them infrastructure? What's so special about it? What's special about infrastructure? Let's ask it that way. Nothing special? We can do without infrastructure? Okay, no, everyone's saying no, right? If you can't do without infrastructure, then there must be something special about it, right? So what's special about it? Why is it important? What would happen if there is no infrastructure? Yeah, it's important for us to survive. How does it make survival possible? Right, you're right. So food and water and all of that also are important for us to survive, right? But infrastructure is not important in the same way, right? I mean, without food, we not die, okay? But infrastructure is important for our survival, but in what way? What does it do? It connects, right? Wonderful. It links multiple systems. It connects, right? It allows us, see, we are a very connected society, connected economy, right? Farmers produce goods somewhere in a farm, far away, right? All of those then need to be brought ultimately to your kitchen or the table in which where you're eating. So it goes from the farm to, maybe wholesale markets to your local vegetable store around the corner. Somebody buys it from the vegetable store, brings it to your kitchen, cooks it and puts it on your table, right? A whole host of transportation infrastructure is necessary to make this happen. If you didn't have transportation infrastructure, then either you would have to live right by the farm, or somehow people would be able to lug it all the way to your kitchen, but probably a lot of the food would get spoiled and rot and all of that on the way. Similarly with people going to work, right? In the old days, traveling about 3-4 kilometers was a Herculean task, right? It would take you an hour by bullock cart. Today with metro rails, etc., or good roads, good public transit systems, you can do that in a couple of minutes, right? There are places in the world where people live about 100 kilometers away from where they work, right? Because they land prices are cheap, or they have good facilities to live in, and they work, imagine, about 100 kilometers away. A journey that used to take multiple days essentially can be done twice on a daily basis, to and fro. Why? Because you have infrastructure, right? Similarly, water supply systems, okay? We have these reservoirs which are full of water, but which are almost necessarily on the outskirts of many cities, right? Because you need a large amount of area to store the water when it rains, right? You can't have that much area within the city because there's a lot of people living. Now, if the water is stored so far away and you're living here, you need infrastructure to connect, right? So all of these kinds of infrastructure, whether it's airports or ports or water supply systems, whatever, essentially facilitate connectivity and become what we call the underlying building block on which society exists. If you didn't have infrastructure, we would still live, but we'd probably live in a very, very different manner. Right, we wouldn't be able to live in this sort of connected society that we live in. We'd have to probably live in very small settlements like we used to do several thousand years ago, right, where each of us would be responsible for our water, our agriculture, whatever, in relatively close societies, okay. But with infrastructure, we now enable connectivity, right. So infrastructure is super important. Without infrastructure, we just can't function, right. By the way, even telecommunication systems are also part of infrastructure, right. So unless you have telecommunication towers and satellites and all of that, you can't send and receive WhatsApps or emails or any of that, right, which are also now, basic to our existence, right. Anyone here can survive without WhatsApp? Right, no one can, right, yeah. So essentially, so you need telecommunications infrastructure as well, okay. So infrastructure is critical, okay. We've talked about why it's important, but a lot of people will say, hey, this is just sort of casual discussion. Okay, yeah, infrastructure is important, so are many other things. Entertainment is important. Can you prove that infrastructure is important? Okay, so there have been a lot of studies that have been done, but I'll show you one that was done by the World Bank about 20 years ago. There's a guy called Cesar Quiroz who plotted a graph. Okay, the x and the y axis. On the x axis, he has a measure of infrastructure. There's a measure of infrastructure. His measure of infrastructure is, take any country. What is the total length of paved roads that they have, right? Because paved roads are a measure of infrastructure. Okay, that's maybe we can come up with different measures, but this is one measure. How much by way of paved roads does a country have? Okay, that's the x-axis. Okay, on the y-axis is the what we call the GNP. What's the GNP? Anyone know what the GNP is? Gross national product. Okay, it's similar to, there's another term that economists often use, right, which we often see in the, it's called the GDP, the gross domestic product, right. We won't sort of split hairs defining the two, but on the y-axis is this gross national product, gross domestic product. What does that gross national product indicate? Somebody says India's GDP is X and America's GDP is Y and Sri Lanka's GDP is Z. What does that mean? What does that number indicate? Net income, it's a proxy, it's a measure for, so if that number is really high, what can you say about that country, right? It's a developed country or it's a wealthy country, right? So in other words, the GNP or the GDP is a measure of how prosperous, developed, wealthy you are, okay? So on the one hand, on the y-axis, you have a measure of, let's say, wealth or prosperity. On the x-axis, you have a measure of the infrastructure quality. Okay, there's the infrastructure quality here. Alright, and I say infrastructure quality because that's why we are emphasizing paved roads, right? I can have some kacha roads and say my country is fully connected, right? But that's low quality infrastructure. Paved roads indicate some quality. So he tried to plot this graph, okay, and said, take any country, how many kilometers of paved roads do they have? What is their GDP like? Now there was one initial problem because people said, hey, wait a second, larger countries are likely to have more kilometers of paved roads. Right, you can say Switzerland is far more developed than India, but Switzerland is tiny, right, it's not even the size of Tamil Nadu, right, and therefore India will always have more paved roads than Switzerland, right, so obviously that's an unfair comparison, right, so how do you reduce that unfairness? Divide by area is one, the other is divide by population, which is what's been done here, right, you divide by population, so you say, yeah, I mean India is a much larger country, you will have larger number of paved roads, but you also have more people. So you look at the number of kilometers of roads that you have per person, right? And then you'll probably find that yes, Switzerland is a small country, but it also has very, very few people, and therefore the kilometer of paved roads per person is quite high, right? So that's a fairer measure of measuring against countries because each country has a different size and shape, okay? Similarly, you do it with the gross national product as well. Again, same reason. The absolute production of a country like India might be much higher than many other countries just because we are large. So you divide it by population to normalize, okay. So he plots GNP per capita by paved roads per million inhabitants, right. So he normalizes the two, but still on the y-axis you have wealth, on the x-axis you have quality of infrastructure, right. And what does he find? Can you guys interpret this graph? What does it tell you? Right, it seems like there is a wonderful correlation. Right, you guys have probably studied correlation regression, I'm sure you did it in 11th, 12th standard, you'll probably do a little bit more of it when you do more statistics, right. But essentially what it says is, and is that the fact that this line is so nice and straight, and all of these points are more or less, all of these points are more or less close to the line, seems to indicate that there's a very good correlation, right? And there's a statistical metric called the R squared, which is also quite high. I mean, R square of 1 would be perfect correlation, so it's not perfect correlation, but it's quite high. What that means is there is a correlation between the quality of your infrastructure and the wealth of a country. Okay. Now we can debate which way is that correlation, right? There's a very important term in statistics that says, or a phrase which people say, correlation is not causation, right? So which way does the arrow point? Because I have good quality infrastructure, am I a wealthy country? Or because I'm a wealthy country, do I have money to invest and do I have better infrastructure, right? We're not going to enter that debate. But the point is the two are related, which means if you want to become a developed country, do we all agree that we want to become a developed country? That we want to become a rich country, comfortable lifestyles, like everyone wants to do that, right? There's nothing wrong there. What that means is you can't do that with poor quality infrastructure, right? Infrastructure is the key. I mean, there are many other things that are key as well. Yes, you have to set up more industries, there should be more manufacturing, you should improve agricultural productivity, literacy needs to be improved. There are many other things as well. But clearly one aspect, right, that concerns all of us in this room because we're all civil engineers is infrastructure. It's very clear that infrastructure is extremely critical to the growth of the country, right? And that's why this community that we are all a part of, the civil engineering community, has an important role to play in India's development because we are essentially in charge of India's infrastructure development. By the way, successive governments in India have also echoed the same statement, right? For the last 20 years, we've been constantly pushing on infrastructure growth, right? Saying we need to develop more infrastructure, more roads, more this, more that, national highways we're trying to develop, we're trying to develop more power infrastructure, we're trying to develop metro rails. There's a lot of infrastructure development and every government has set itself targets from the time of the old planning commission to Niti Aayog currently, right? So it's not that I'm the only one saying it, right? We all recognize at the highest level, the prime ministers of this country have also recognized this. So infrastructure is key, right? Let there be no doubt about that. Okay. Next question, infrastructure is key. How is India's infrastructure? Good, bad, ugly? Okay, how many of you say good? India's infrastructure is good. Okay, maybe 11. Okay, we have class size about 100, right? Okay, India's infrastructure is bad. Okay, so that's about 42. I'm very experienced at doing this. Okay, India's infrastructure is ugly. Okay, no one thinks it's ugly. Good. So that means a bunch of you haven't voted. This is like our Indian elections, no? Right? Everyone's checking that last, I don't want to, the nota or whatever we call that. Okay. But essentially, how is India's infrastructure? This is what it looks like, right? These are pictures that I'm sure you could snap with your camera, right? Most roads are highly congested. So I had a meeting today 6 kilometers away, right? And it took me almost, before this class, it took me almost 50 minutes, right? To get from my meeting to here, right? And if you do the calculations, I was probably traveling at about 7.2 kilometers an hour, right? Extremely slow, right? People run faster than that, okay? Housing, we all know there's a huge housing shortage, there are lots of sort of slums. Of course, government is addressing all of this. You have something called the Pradhan Mantri Awas Yojana, we're trying to build houses, but there still is, as of today, huge housing sort of shortage, right? Lots of taps don't have water running through them, right? Because we have a large population, we've probably not managed our water resources as well. Rainfall patterns are varying. In Chennai right now, we've been in a crisis for quite some time, right? All of us are praying to various gods and doing various things, hoping that in about a month we'll get a good northeast monsoon. Otherwise, I don't know, IIT Madras might have to be relocated, okay? So, and of course, we all know this, right? This is a picture, as you can imagine, from Delhi, but because of, poor infrastructure, there's also pollution, etc. So, essentially, I think there are certain parts of India's infrastructure which are not bad. Some of our national highways are good. It's good that we're getting metro systems. Our telecommunication systems have evolved quite well, all of that. But obviously, there's still a lot of work to do, right? So, if you have a report card, we are not getting a distinction just yet, right? We still have a lot that we need to do, okay? So how do you go about building this infrastructure, right? There is typically a process that we follow, right? So I will just quickly take you through the stages of this process. If you want to build anything, it could be a desalination plant, a road, a power plant, a dam, housing, whatever it is. You often start off with what we call a preliminary feasibility study, right? First, we've got to establish, is this piece of infrastructure even required? Okay, so I want to build a desalination plant, right? You guys know what a desalination plant is, right? It's this big plant that we normally build off the coast, which takes seawater and through, essentially removes the salt, which is where the term desalination comes from, and creates drinking water, right? So I want to build a desalination plant. So the question is this even feasible? First, is it necessary? Right? Do you need a desalination plant? Right? Can you show that you have a water sort of risk? Second, are you even close to an area which can be desalinated? Do you have a coastal presence? How expensive will it be? Will there be people who want to buy this water? So a lot of initial questions need to be asked, right? Just because somebody says, I went to a conference abroad and I learnt about this desalination technology, let's build one. Right, doesn't mean you have to jump in and build. So you do a bit of preliminary feasibility. Do you have the land available? Do you have the requirement? Roughly what is it going to cost? Do you have the money for it, etc. Right? If at the end of preliminary feasibility you might say this project is probably not going to happen. I mean, it's an interesting project, but it's way too expensive, we don't have the money to do it, right? Or it's an interesting project, but I don't have land. I mean, I'd really like to build a road that connects A to B, but that entire path passes through some very fertile farmland, and therefore I can't really build that road. So we might say no, right? But if you say yes, this project is feasible, then you actually go into stage 2, where you actually start doing some detailed analysis. And this is where a lot of the civil engineering that we study comes into use, right? Because if I have to build a desalination plant, let's just use that example. I have to do some structural design, right? I've got to figure out, I've got to put the plant somewhere on the coast. I have to design the foundations. I have to design the structure. I have to design the water treatment systems. What kind of filter am I going to use? All of those kinds of things. Where will the water flow? How many pumps do I use? Where does the electricity come from? So you have to start doing some detailed engineering design. And also figure out, for instance, where is this money going to come from, right? If it's going to cost me, say, 5,000 crores, right? Where is the 5,000 crores going to come from? Anyone here have 5,000 crores in your back pocket? Okay, no, I thought not. If you do, please come and talk to me after class. Okay, so so this money needs to come from somewhere. Maybe government has some money that it can put aside, right? But maybe government doesn't have money, right? In which case you might have to sort of look at, can the private sector give me some money? Can banks lend me some money? Can I go to people like the World Bank, right, who are trying to help countries develop and ask them for some money? Of course, all of this is not free money, right? It's a loan, which means, do I have the capability to repay that loan? The taxes that I'm collecting, is that enough to repay? And therefore, this water that I'm generating out of the desalination plant, what is the price that I should sell that water at, so that I will get enough money to repay my loan? So all of these are calculations that you need to do, right? And they are iterative, right? You will say, okay, looks like if I charge 40 rupees a kiloliter, this project will work. But then people around might say 40 rupees a kiloliter for water, that's ridiculously expensive, right? I can't pay that. I'm not willing to pay more than 20 rupees a kiloliter, right? So if you charge 40, nobody will buy your water, right? So then you charge 20, but if you charge 20, you can't pay the loan, right? So how do you've got to figure out a solution to this, right? Either you find another source of funds, or you negotiate with people. Somewhere or the other, you have to solve this problem. So it's a bit of an iterative kind of problem. Once you've come to that and you've figured out that, yes, this really works, it was feasible, and I've now found a way for it to work. I've designed it, I know exactly what it's going to cost, I know exactly where I'm going to get all my materials and components from, I know exactly who is going to give me money, who is going to give me loan, what interest rate are they going to give me at, how am I going to pay back. Once I decide all of that, I can go to stage 3, which is actually finding somebody to build the project, right? Because when we say this has been built by government, right? Government has not built it, right? It's not as if the chief minister or the prime minister is there every day pouring concrete, vibrating, etc., right? Obviously, that's not the case, right? You've got a contractor to build it for you, right? So you have to then go through a process of selecting the appropriate person, right? And that is not, that's not very easy. Obviously, you want somebody who is cheap, right? But also high quality, but also reliable, right? So all of these kinds of things, right? Sometimes the cheapest fellow is cheap because he is not high quality, right? So this is facts of life, right? So or he has good quality but is not reliable, right? So how do you find, and there is sometimes you are searching for this mythical contractor who is cheap, high quality and reliable, etc. It's difficult. So you have to try to find out who is the best person possible. It might also be that such a person exists, but because this person is high quality, reliable and cheap, he already has a number of other projects, he or she, that they are performing, right? Which means when your project comes up, the person says, sorry, I have only so many people in my organization, we are already spread too thin, working all across the country, I can't work for you. So this process of what we call procurement, right, is an interesting process, right? On the one hand, you want to be fair, you want to give everyone a chance, because you never know, there's some innovative person with some ideas, you want to sort of use them. right? But unfortunately, if you say, who would like to build this for me? India is a large country of 1 billion plus people. What if 1,398 companies come and say, we build it for you, right? You've got to find some way of selecting one, right? So you have various stages. Sometimes you might say, let me do what we call a pre-qualification process, right? Let me first select only those people. So let's say I have to build 100 million liters a day capacity desalination plant. Let me select people who have built a minimum of 50 liters per day desalination plant. In other words, if you're a road contractor, don't even come, right? Because you clearly don't know how to build my project, right? So you have to have built some desalination plant, and then further than that, you can say, not just any desalination plant. Don't build some small 5 million liters a day plant and try to build my 100 million liters a day plant. You should have at least built 50, right? So you have a pre-qualification process. Then after that, you might look at both your financial and your technical competency. So give me a technical proposal. How are you going to build it? And tell me how much it's going to cost, right? Because like I said, let's not just take only the low cost person, because they may not necessarily be the most high quality or reliable. So you can, sometimes this process takes time, finding Mr. or Miss Right, right? And this is important because if you're stuck with the wrong person, right, it's going to be trouble, because these projects are going to take 2-3 years to construct, okay? So there's a procurement stage that becomes very important. Once you've procured it, then you can actually start construction, right? And this is where a lot of what we generally teach, and you'll take this class when you come to the third year, whatever, on construction planning. So you've got to plan out the construction, you've got to sequence the various activities, you've got to make sure that when a particular activity needs to be constructed, that material is available, people with that skill are available, right? We like to talk about construction laborers, right? But the point is that different kinds of laborers. There are carpenters, right, who are very good at woodwork, right? There are bar benders who work with reinforcing steel. There are masons who work with cement. So you can't just say, give me 10 laborers, right? You need, for a certain kind of job, you need carpenters, you need bar benders, you need masons, you need, people who can operate certain kinds of equipment, right? None of us can just jump into a crane and start operating it, right? It takes a little bit of skill. So you've got to sequence all of that, plan, make sure that the right person is available at the right time, the materials are available. Some materials can be bought instantaneously, right? You can buy material today and use it tomorrow. Others will have to be ordered months in advance, right? You're building a palace with Italian marble, right? You can't say, I want to lay my marble today, where is it, right? You had to, by definition, you have to order it from Italy, right? Which means it will take its own time coming in, it will have to go through customs, etc. So all of this has to be planned, right? And finally, once you've finished constructing, right, you have what we call operations, right? Where you run and operate the facility. Now, hardly anyone talks about this, but that's quite strange, because it takes maybe a couple of years to build a desalination plant. How long would you think you want to use that desalination plant? Or a building, it takes about a year to build your house. How long are you going to use your house? 20 years, 30 years, 40 years, 50 years, for a long time, right? Which means it's very important to take a lot of care in terms of how you operate it, right? When do I maintain, how do I maintain? All of this is because it's not enough to build something. You're building something because it creates value, right? And it's going to create value only if it's operated and maintained well, right? So this entire thing is the infrastructure life cycle, right? You start off with an idea right here and you end up with an operated facility there, right? But although I've drawn a nice step ladder kind of diagram, the process unfortunately is not so linear, right? The process ends up being far more messy and far more iterative, right? And the reason behind that is a very important word. How many of you have come across this word before? How many of you have heard the word stakeholders? Yeah, many of you. What does stakeholder mean? Right? Definition simple, right? It's person who has a stake, who holds a stake in the project. Therefore, they're a stakeholder, right? So if I take any project, let's take a road. Okay, who are the stakeholders in that project? Right? Who are the stakeholders in a road? I'm going to build a road from A to B. Okay, who are all the stakeholders in that project? And you start thinking about this, right? You find there are lots of stakeholders. Of course, the government agency is clearly a stakeholder. The agency has hired some consultants to do their designs, etc. That's a stakeholder. You've hired a contractor. But to construct that road, you're probably acquiring a lot of land, right? Which means all of those people who own land are stakeholders. Some of them will have to sell their land. Some of them will not sell their land and somehow see their land prices go up because now they're next to a road, right? Some of that land might be farmland. That road might also be a corridor for certain wildlife going to and fro, which means you have all kinds of environmental groups that might also be stakeholders. They have something to say about the project. You might have existing water lines or telegraph lines or power lines along the alignment of that road, which means those departments are also stakeholders, because in order for you to build the road, you will have to shift the water line or whatever. So there are tons of stakeholders, okay, and many stakeholders have their own interests, okay, which they have to actually, which they will want to protect, right? So stakeholder management is a big challenge that appears in every single phase of the project, right? And if you want to know why stakeholder management is so difficult, tell me what you see here. What do you guys see? Okay, some of you see a tree, right? So this is a tree, there's sort of a nice, there seem to be two birds here on top. This is the root of the tree. What else do you see? Right? Others might say, hey, wait a second, just look at the white part, right? This looks a bit like, I'm probably messing it up, but this looks a bit like a lion or a lioness, right? And this looks a bit like a gorilla. Okay, this is a gorilla. So it's a gorilla and a lioness looking at each other, right, with some black space in between, and not, a tree with birds. Okay, so there's multiple perspectives. What do you see here? Okay, see an old woman. How many of you see the old woman? Okay, anyone see anything else? Okay, how many of you see a young lady with her face turned away from the picture? Yeah, so for those of you who wanted to look at the old woman, this is the old woman's chin. Okay, chin, this is the nose, whatever. For those of you looking at the young lady, this is the young lady's nose, this is the young lady's chin, and this is her hair, and these are her eyes, right? And she's turning away, right? These are all called what we call gestalt images, right? And you guys have this slide, so if you can't see it right away, you can sort of go back home and try to look left, right, center, etc. Last one, what do you see? Huh? Alright, so on the one hand, some of you see two faces. This is face 1 and face 2, as if they're talking to each other, but it probably also is if you look at it, it's sort of like a cup, like or a goblet or a chalice or something like that. So just focus on the white. Well, I can't, unfortunately, closing it here doesn't close it there, so it doesn't work. But you can just look at the center white, it's sort of like a goblet, right? So lots of these kinds of images. If you want more fun, go and Google Gestalt, Gestalt, Gestalt images, and you'll find a bunch of these, right? The reason I'm showing you guys this is, one, to keep you awake, of course, but second, also to show you that people can have multiple perspectives, right, on the same thing, right? Some of you can say gorilla and lion, some of you can say tree, some of you can say young lady, some of you can say old lady, but I'm showing you all the same thing, right? Similar with stakeholders, right? It's the same project, but different people perceive it differently, right? You look at for instance, a dam, right, that you're building. Some people look at that dam and say, wow, this is going to generate hydroelectricity, right? It's going to sort of store water that we can use for irrigation, etc. Others are going to look at the same project and say, you're going to flood the nearby areas. You're going to displace people, right? You're going to destroy environments, right? So same project, people can look at very differently, right? And this is something that you will have to work with, because whether you like it or not, stakeholders can cause a lot of challenges on projects, right? And I'm not saying that stakeholders are wrong. Sometimes they have very good points of view. These are two newspaper clippings from projects that have been very recent, from things that have happened very recently in Tamil Nadu, right? Just because you guys are all at IIT Madras, right? You can pick your own state and you can find others, right? Sterlite had a industrial mining facility that they've just recently closed down because of stakeholder protests, right? Recently we've had something called a Chennai-Salem Greenfield Corridor, right, between Chennai and Salem, which farmers are opposing, right, because it essentially says it will destroy their forest areas, lands, etc. Right, so you have many of these projects. You can think of the Narmada Bachao Andolan. Some of you might recognize that, right? So stakeholders are capable of protesting quite a bit to stop projects, because not everyone sees infrastructure projects as beneficial. Globally, we all agree that infrastructure is good, but what you need to understand is, for every single infrastructure project, there will be winners and there will be losers. Right, this is just how the world works, right? This is great. I built this road from A to B. I am able to go from Chennai to Bangalore in 4 hours. I don't need to fly. I don't need to take a congested train, right? So that sounds good to you, but there are some people who lost their land, right? And those people probably don't view that as such a nice project, right? So there are always winners and losers, and losers are obviously not going to die quietly, right? Nobody is going to say, okay, please take my land, right? I'll be unhappy. That's fine, right? Let that other fellow be happy. right? Very few people will actually, say these kinds of things, okay? People are going to try to protest and say, why do you need my land, right? Why can't you have an alternative route? Why is this project necessary, right? So you remember that step ladder diagram I showed you? Every step of the way, from preliminary feasibility to detailed studies to construction, stakeholders will keep coming and opposing projects, which means if you want to talk about stakeholder management, right, you've got to talk about how do I actually manage all of these protests that comes in, right? And when you look at infrastructure management, that's the hard part. The rest of it, designing your bridge, etc., can be done, right? We have enough theories on how to do it. Today's software are strong enough that once you put in the right boundary conditions, you can probably get a design out, okay? But the stakeholder management part is far more difficult, and the reason is people don't behave like electrons, right? Electrons have the same behavior irrespective whether it's an electron in the US or an electron in India or an electron in, here versus there, whereas people are all different. It's very difficult to control them, okay? And if you want a project to be successful, it needs to be economically viable, right? There needs to be some economic benefit out of it, but it also needs to be beneficial to people. Everyone needs to sort of, or a large majority of people need to be included in those benefits, and increasingly today, we also need to be environmentally conscious, okay? If you do that, you get what we call a sustainable infrastructure project, okay? If you mess up on one of these, it comes back to bite you. If you've got a project that's economically hugely beneficial, right, but socially disastrous, people are going to be charged huge amounts of money to use a particular road, or you're acquiring a lot of prime farmland, all of that, then very often the protests will end up destroying the project, as they've done with several projects, right? So all three need to be balanced in infrastructure development. That's very, very hard, right? I gave you the example of a dam, right? This is just a hypothetical dam. Like I said, there are clearly economic benefits to a dam. You can generate power, you can sell power, right? You can store water, you can irrigate fields, you can improve farming productivity, right? You can supply water to people, you can pay them for that. So you can charge them for that. So there are economic benefits, but there could be social disbenefits, because when you build a dam and the water actually floods across a larger area, you might be displacing people and villages who live at the borders of that dam, of that river that is now being dammed, right? So what happens to those people is an important question that you'll have to answer. Similarly, you will be destroying flora and fauna around that dam. What happens to those natural ecosystems which provide some service, right? Cutting down trees is not an answer, right? Because trees help sequester carbon, which is very important if you're trying to combat global warming. So you can't just say the tree doesn't have a voice to protest, let me cut it down, okay? So if somehow you can keep people happy by maybe finding them an alternative place to live and an alternative livelihood, and if you can find out a way to mitigate the environmental damage that you're causing, then dams can be hugely successful, right? Otherwise, in some cases, all of these protests and the political machinations that follow might end up leading to a situation where the dam is not constructed, or after it's constructed, there are so many protests, people try to sabotage the dam, etc., right? So building infrastructure, managing when we say infrastructure management, right, many of you probably came into this class thinking about, okay, what are the various civil engineering aspects to it, and those are important. I do need to figure out how to design the foundation for this dam. I do need to figure out what is the strength of concrete that I need to use for this dam. But I also need to figure out, and that's more difficult, what are the economic benefits, what are the social benefits, what are the environmental benefits, what are the disbenefits, and how can I mitigate? And if you can do this, then you are an infrastructure manager, right? And when you come to fourth year, we will have, at least I teach a class which goes into detail in all of this, and there are other classes that you can take as well to understand this. So what are some ways in which you can do this? I'll give you a few examples, and then we'll sort of maybe take a few questions today, but I think we'll find some other time for more detailed discussion. One of the ways of doing this is to allow people to visualize, right, what this project is going to look like, right, in the future. Very often we end up talking in the abstract, right? So I've got all of these poor people, I want to resettle them into these kinds of houses. People start protesting, right? I want a house like this, I want a house like that. All of it is conceptual. What if we could actually show people what it really looked like? In the past, you have architects showing you 2D drawings, right? 2D blueprints. Many of you have probably seen a blueprint at some point or the other, right? Maybe you had a house that you were building or your friends were building. Maybe you saw it in a movie, right? So these are plans that try to indicate what the structure looks like. But guess what? Even an experienced civil engineer finds it difficult to understand what that blueprint is talking about, right? It's a bunch of lines and grids and annotations, etc. I want to try to close my eyes and try to figure out what is this thing going to look like, okay? Very, very difficult. But today with technology, I can actually build these kinds of three-dimensional images of what the finished product might look like, whether it's a house or a dam or whatever, and we can start doing simulations to say, look, here's sort of the width of the river at this point. Here's what the width of the river is going to be like, and therefore all of you villages here don't really need to worry, right? The width of the river won't really encroach upon your village space, and as a result of which you guys don't need to protest. If at all, fishing etc. is going to be easy for you because you're going to be closer to the river, right? So you can actually start helping people visualize, and that might be one way in which to get stakeholders together. It might also be a good way for stakeholders to come in and give you suggestions on the project, right? Let us not be under any impression that there is this infrastructure project manager who knows the best way of building these projects. There's no such thing, right? People sometimes have a wonderful idea of why don't you build the dam a little bit more downstream, and that's probably a better location for the dam because you're causing minimal environmental damage, and by the way there's a natural slope, so the hydroelectric power you generate might be higher, right? So you never know when people will come up with ideas. So showing them, helping them visualize, right, is an approach that you can use to bring stakeholders together. Again, 10 years ago, 15 years ago, neither the hardware, the computers, nor the software was strong enough for us to really convincingly visualize. So what people used to do is they used to play these kinds of movies, right? So you've probably seen, there'll be a movie, a walkthrough of a building, people standing around playing basketball, working, and people will say, look, this is a wonderful facility that you're going to get. So those are essentially animations, right? But we can go a step further today. We can make these dynamic, right? We can actually have meetings where we're sitting around with stakeholders, and in that meeting, be able to understand what happens if I move my dam up a little bit, right? What does it do to the width of the river? What does it do to the hydroelectric power that's generated, right? And it's almost like a flight simulator, right? Do a bunch of what if scenarios, right? Or if you're going to build urban housing, you have only a certain amount of budget. You want to build low cost, low income housing, right? You can quickly try out a few designs, have people literally walk through these designs. Today, we're all familiar with 3D cinema, right? I mean, almost any time you go to a cinema theater, most movies today are in 3D, right? So you wear these 3D glasses. Why can't you do the same thing to a simulation, right? Wear a 3D glass, right? And immerse yourself in the model. So for a second, right, you're actually walking through, right, a simulation of the real model, right? All of these technologies now exist, and I believe you will have a talk later by Professor Koshi on automation, where he might touch upon some of this, right? But you can actually now really help immerse people into a piece of infrastructure that you're going to build, and through that immersion process understand more what their concerns are and try to sort of dynamically redesign and come up with a design that everyone by and large signs off on, so that as you start constructing you have fewer protests, right? So new technologies for better visualization is one key strategy. Second, and this is sort of a part of a project we're doing currently, is can I start simulating future outcomes to make better decisions on what infrastructure to plan, right? So, we are now in 2019, about to get to 2020 in Chennai, okay? What will Chennai look like in 2030? Okay, it's a very difficult question to answer. A lot of people may move into Chennai, people may move out of Chennai, right? Certain kinds of facilities may get built in Chennai, certain kinds of facilities might get raised down in Chennai, right? In the middle, people might say, okay, let's build a metro rail or something like that, right? Rainfall might be good, might be bad. If rainfall is good, if rainfall is better than normal and you've actually built a lot, there might be a risk of flooding, right? So there's so many future possibilities, right? We could sit for hours and we could list out potential future scenarios, right? Some of them might make good scripts for movies, right? Like The Day After Tomorrow or all of these kinds of movies, right? You guys have not seen that movie? Okay, some of you have seen it, so you know what I'm talking about, right? But what you could do is, if you can actually start simulating various futures, you can actually start thinking about, hey, if these are the kinds of futures I want to get to, and these are the kinds of futures I want to avoid, what kind of infrastructure do I need to build today, right, to get to the futures that I want to, right? So, rainfall is going to become, the rainfall patterns are going to vary more and more, right? That seems to be an impact of climate change. In my mind at least, there is no doubt that climate change is upon us, right? Climate patterns are changing. And because of that, you will have these years where you will have bumper rainfall, you will have years where you will have drought, which is now problematic for me from a water perspective. Ideally, I'd like the same amount of rainfall every year, right? So I know exactly how much I can store in my tank, right? But if you're going to give me double the amount of rainfall in a particular year, I can't store that much. So what do? Half of it runs into the sea. The next year, I don't have enough rainfall, I can't ask the sea to give that back to me, right? Doesn't work that way. So I have to now figure out, so what is the kind of policy that I can put in place today, right? That might help me stabilize my water infrastructure in the future, right? And can I simulate the impacts of that policy, right? So I think all of these urban simulations, I think are very important tools for us to understand the future, for us to bring in stakeholders and say, look, you guys want to build more and more houses, guess what? Right? The problem with building all of these houses is that, and building all of these roads, is that you're creating less surface for the water to percolate down, because you're making everything into concrete, because of which the water is going to flow and you're going to have flooding. Okay, so can we look at an alternative building trajectory, right? Can we start not building in the city but start building more horizontally along the periphery in suburban areas, right? So, and can we bring along potential house owners and builders, right? And have everyone sort of agree to that strategy, because they are all the stakeholders to this. So simulations, I think, are a very important part of working with stakeholders, being able to help them understand what are the near-term effects and long-term effects of of developing infrastructure. And by the way, these are not done yet, right? There's still a lot of R&D that's going in, right? So these are all potential projects that you might want to work on, right, throughout your tenure at IIT and even later, okay? Once you get to that, once you have your stakeholders on board, then there is sort of a relatively systematic process that you can follow, right? So first somebody comes in and says, okay, we're all agreed, right? So this is the kind of infrastructure we want. Okay, now let me go design it. And this is the kind of blueprint I was referring to, right? So you have now a clear plan, right? You have dimensions. Where are some dimensions? Yeah, so you have levels and dimensions and all of that, and it's very clear, right? So somebody can look at this and say, this is the amount of concrete that I need to build this structure, right? Because it's fully planned out. I can go to each and every concrete element, I can figure out, is it cylindrical, is it cuboid, I can use my volumetric mensuration formulas that I learnt in 5th standard and figure out exactly how much concrete I need. Then I can start looking at who will supply me that concrete, will they give me a discount because I'm buying a large amount, all of that, right? So you can go in with the detailed design of projects. Once you design projects in detail, the next step is what we call cost estimation, right? So you've designed it, somebody has given you this blueprint, right? Somebody has given you this design and say, this is what you've all agreed upon. Then you actually do what we call a quantity takeoff, and you say, okay, here are the various items, okay, there's some steel, there's some concrete, there's some drainage, okay, in what we call the footings, right, there's some sand and mortar in the foundation. So for each of my elements, I have certain what we call items of work. Each of those items of work, I have a quantity. So for instance, in the foundation, concrete is 20 cubic yards, right, and the price per cubic yard is 115 whatever, dollars, rupees, I think it's dollars is where I picked this out from, okay. So I can actually find out in the footings how much is my concrete going to cost, right. So I can do a very systematic cost analysis for every aspect of my work, right. This particular structure, right, so I'm building a metro rail, right, the metro rail has all of these tall piers on which the metro rail stands on, okay. How many of those piers do I have? How much cement goes into those piers? How much steel goes into those piers? What are the items? What is the quantity and what is the rate? Right? Today's market rate, what is cement? 250 rupees a bag, 300 rupees a bag, 325 rupees a bag. Similarly, steel, right? Per kilogram or per ton, what is the amount that they're charging for? And I can come up with a very detailed estimate, right? And of course, if you're a contractor, you'll put in your profit, etc., which is all fine. Okay. So first stage is, once you agree with stakeholders, first stage is design. From design, you come up with these quantity estimates, so you have a bit of an idea of how much this is going to cost, right? Then you go more or less try to figure out, where is this money going to come from? Do I have it with me? Do I have to borrow it, right? When contractors come in and bid for your project and volunteer to do it for you, you can compare their cost against this, right? Everyone will have a slightly different cost. For you, it's 115, rupees or dollars per cubic yard. Somebody might have a rate discount because he builds a lot, right? India Cements might give him concrete at a slightly cheaper rate. He might say 110. Right, or plus or minus, right? Or somebody might say, oh, the price of cement is actually going to go up, so my concrete price is going to be a bit higher. So there's always be fluctuations, right? But at least you can compare somebody's bid with what you've come up with and sort of see, okay, this is about in the right ballpark. So this is step 2, estimate. Once you've estimated, you've selected a contractor, etc., you've got to schedule the project, you've got to plan it, what comes first. I've got to obtain materials, then I've got to construct the garage slab, then I construct the driveway. After I construct the slab, I can erect the walls. See, some of these things happen in sequence, some of these things happen in parallel, Okay, so this is sequential, this is parallel, right? So there are very many ways in which I can sequence a project, right? So I've got to think carefully, do all of this sequencing, etc. And once I've done all of that, my final task is to actually monitor the construction of that asset before I hand it over to somebody to operate and run and live and use and whatever, right? And today monitoring, of course, you've got to be at the site to monitor, right? So that's why we have a person with a hard hat, etc. But today's monitoring, what does this person have in his hand, right? It's some kind of a tablet, right? It could be an iPad, it could be some other model, but he has a tablet, right? Because a lot of this is now digital, right? So he has a lot of digital information. So he, for instance, has a drawing of exactly the area that he's standing in, or maybe even better, a three-dimensional image of what that area should look like. Looks at the image, looks outside and says, okay, or he says, hang on a second, there should be an opening there, and there's an opening here in this drawing, but there's no opening there, right? And so he reports an error and you correct. So at any given point of time, you've got to monitor. You can't just say, here's a design, thank you, bye-bye, I'll come back in 1 year and I want to see that finished structure. Doesn't happen that way, right? You've got to monitor that the work is being done as per the plan. And today's monitoring is starting to become more and more automated, more and more digital, along with these kinds of tools, okay? So once you've done that, you can actually hand over the project for operation, right? So in some sense, and this brings me to the end of today's presentation and not a minute too soon, it's exactly 11:50. But essentially what I wanted to do is to give you an overview of infrastructure and construction project management, right? On the one hand, you can simplify it and say, okay, I've got to come up with the design, I've got to then come up with costs, I have to schedule it, and I have to then construct it and monitor it. But there's also a lot of other stuff, right, that goes in. You've got to sort of first convince people that this is feasible, you've got to do detailed design, you've got to find a contractor, there are stakeholders everywhere who will come in, who will start protesting. And by the way, there's no such thing as all the protests are done, right? Imagine you're building a water treatment plant somewhere or wastewater treatment plant like what I showed you, right? Initially, some people might come in and they might protest all of that, you might satisfy them. And then when you're constructing, people in the neighborhood might come up and say, hang on a second, I didn't realize this plant was going to be so close to where I live and I don't want to live next to a water treatment plant. I completely agree that we need wastewater treatment plants in the city, but not next to my house, right? So not in my backyard, right? NIMBY, there's an acronym, right? I don't know if you guys have heard this. NIMBY stands for not in my backyard, right? Essentially says, I want this, but please do it somewhere else, not here, okay? And this protest might come very, very late, right? After you've awarded the contract, after you've bought the materials, after you've started the foundation, people might start protesting. So there's no such thing as check the box, my stakeholders have all disappeared. So this whole stakeholder management piece, right, is a very, very important piece in the whole infrastructure project management, in addition to the engineering design, the costing, all of that. And while we will teach you a lot of the engineering design piece, the stakeholder management piece requires a bunch of other skills. It's not enough if you're good at mathematics, unfortunately, right? You can't deal with stakeholders that way, right? You need to be good at, you need to have great interpersonal skills, you need to have sort of charismatic leadership, you might need to have a really good understanding of legal issues, the law, when you can apply the law, when you can't. So what that means for people like you in the room who might want to look at a career in infrastructure going forward is your civil engineering fundamentals are important, right? But beyond that, you almost also have to skill yourself in economics, law, management, sociology, all of these, right? And the really successful infrastructure managers are the ones who are multidisciplinary, right? Who have all of these, either they've studied it or they have an aptitude for it or they've read about it. You choose the way you want to go, right? But if we remember the beginning, we said India's infrastructure is not as great as it needs to be. We need to build infrastructure. We need to surmount all of these challenges, technical, non-technical, and you guys will have to develop a varied skill set to do that, okay?